Okay, part B now of the same FRQ. Explain why there must be a value, an x value again, between 1 and 3 where the slope of h, the tangent slope of h is negative 5. So on part A, they were asking for you to remember the intermediate value theorem. Here was part A again, because they're asking for a value of h. Now that they're asking you to confirm that there is a tangent slope of h, that's the mean value theorem. That is on the golden notes. So I've got to think of h as being, now I know from part A that h goes this direction. So h does whatever. The point here, I figured this out in part A, is 1, let's double check, 3. This point is 3, negative 7. The mean value theorem says as long as h is continuous and differentiable. So I know that from the same reason I do that in part A. So I've got to find the secant slope here, the slope between the points. So this secant slope is going to equal negative 7 subtract 3 divided by 3 subtract 1. This is negative 10 all over 2, or negative 5. So I need to show this computation right here. I don't need anything else, but I need this computation in order to get 1 point. Then I have to do the right wording to get the second point. So let's copy this over. Clear this off. The wording would be this. Since h of x is continuous and differentiable, the mean value theorem, well, I think a better way to say it is because h of x is continuous and differentiable, and h of 3 subtract h of 1 divided by 3 subtract 1. Notice how I'm using the mean value theorem here. It's just the formula I'm working with is called h instead of f. The interval is from a to b, which is from x equal 1 to x equal 3. So because I found this already to equal negative 5, then I can state the following. Since h is continuous and differentiable, and this is equal to negative 5, therefore the mean value theorem guarantees, or I guess a better way to say it would be to say by the mean value theorem, h prime of some x coordinate must also equal negative 5 for that x coordinate lying somewhere between x equal 1 and x equal 3. It's a good example of where you have to be really specific and keep track of x coordinate versus y coordinate, tangent slope versus secant slope. If you have all of this in brown, you would get the second point. Part B is worth 2 total points.